Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. I'm excited to dive into the details of the Mobile ALOHA system with you. Could you explain how the system integrates a mobile base with ALOHA arms to support bimanual tasks and whole-body teleoperation?
Sure. Imagine you have a robot friend with 2 arms and a set of wheels like a skateboard. The Mobile ALOHA system is just like that robot friend. It has 2 special arms that can do tasks like pouring liquid or opening doors. These arms are great at working together, just like how you use both hands to do things. Now, this robot friend also has wheels, so it can move around like you when you walk. This helps it reach different places to do tasks, just like how you move around to get things done. By combining the moving ability of the wheels with the helpful arms, Mobile ALOHA can do a lot of tasks in your home, like watering plants, cooking, or even greeting people. It's like having a handy helper that can both move and use its hands to do things for you.
That's a fantastic analogy. It really helps paint a clear picture of how the Mobile ALOHA system functions. To delve a bit deeper, could you explain how the data collected with Mobile ALOHA is utilized in the supervised behavior cloning process?
In the supervised behavior cloning process, the data collected with Mobile ALOHA is used to teach the robot how to perform specific tasks by imitating human demonstrations. The robot learns from the demonstrations provided by human operators and tries to mimic those actions to accomplish tasks autonomously. This data is crucial for training the robot's policies to perform tasks accurately and efficiently.
It's fascinating how the robot learns from human demonstrations to perform tasks autonomously. Moving on. Could you elaborate on how co-training with existing static ALOHA datasets enhances the performance of the Mobile ALOHA system on mobile manipulation tasks?
Co-training with existing static ALOHA datasets enhances the performance of the Mobile ALOHA system on mobile manipulation tasks by combining the knowledge from both static and mobile manipulation datasets to improve learning. It's like having 2 friends who are really good at different things, and when they work together, they become even better. The static ALOHA dataset provides valuable information and examples that help the Mobile ALOHA system learn faster and perform tasks more efficiently. By training Mobile ALOHA with a mix of both types of data, the system can achieve expert-level performance with fewer demonstrations, making it more effective at tasks like wiping wine, cooking shrimp, or rinsing pans.
The analogy of 2 friends with different strengths coming together to enhance each other's abilities really illustrates the concept of co-training with existing static ALOHA datasets. This collaboration of datasets seems to significantly improve the Mobile ALOHA system's performance on mobile manipulation tasks. Lastly, could you highlight the significance of the study's findings in the field of robotics and imitation learning?
Study's findings on co-training with static ALOHA data hold significant importance in the field of robotics and imitation learning. They provide a novel approach to enhancing the learning capabilities of robots through a collaborative learning process, similar to how friends learn together in school. By combining 2 sources of information, the robots can improve their understanding and performance, much like how working together on a project can lead to better results than working alone. This can lead to more efficient and effective robotic systems that can learn from limited data, making them more adaptable and capable of imitating human actions and behaviors.
The analogy of 2 friends with different strengths coming together to enhance each other's abilities really illustrates the concept of co-training with existing static ALOHA datasets. This collaboration of datasets seems to significantly improve the Mobile ALOHA system's performance on mobile manipulation tasks. Lastly, could you highlight the significance of the study's findings in the field of robotics and imitation learning?
The significance of the study's findings on co-training with static ALOHA data in the field of robotics and imitation learning is that it shows a more efficient way to train robots to perform tasks by leveraging diverse datasets. Traditional methods require collecting new data for each task on a specific robot study, which is time-consuming. Co-training allows robots to learn from a mix of datasets, making them more robust to different conditions like changes in lighting or distractions. This approach outperforms pre-training methods and reduces the need for manual adjustment when introducing new tasks. Overall, the study's findings pave the way for more effective and versatile robotic learning, improving how robots can adapt to different environments and tasks.